Hello everybody, welcome to STN-Bit. In this channel we discuss network automation and programmability concepts. In today's video we're going to continue exploring Containerlab and its brilliant features, and I will run a lab to demonstrate what happens to your network when you disable STP on your switches. We're basically going to wreak havoc in our network. So let's go ahead and get started. I'm going to open up VS Code directly and it will automatically open the lab 21 directory where I store all my files and folders, and this directory is linked to my GitHub repository, which means all the work that will be done in this video will be pushed to a remote repository later, and this means that you can clone the contents of that repo and work on it if you want to. So I'm gonna open a new terminal in VS Code, and it will show you the fast fetch output in case you're interested in what local workstation I'm working on, and its setup and just general information about it. So I'm gonna go ahead and create a new folder. I'm gonna call it Storm because we're gonna cause a broadcast storm in our network. And here I'm going to create a new file and I'm going to call it Storm as well, because why not? So I already basically have some files here, some topology definition files to run webs in Containerlab, obviously. So I just want to confirm which Containerlab version I'm running right now. It's going to be 0.73.0. All right, so let's go ahead and just open one of these, let's say this one, and it will help auto-completion. So I'm going to call it Storm. I don't like prefixes, so I'm just going to omit prefix. Topology, this looks exactly good. It's like from my previous file, but I'm going to delete this part. So I don't need this one either. Network mod none, we don't need this feature because I like to keep default management network of Containerlab so I can directly SSH into devices. So very simple web which will consist of 3 switches, and all these switches will be interconnected to each other in triangular fashion. So if I just keep pressing tab, it will do the job. Looks good. So switch 1 is connected to switch 2, switch 2 is connected to switch 3, and switch 3 is connected to switch 1, which means we will have a triangular switch topology. All right, so I'm going to save this simple file and I'm going to run it, deploy it. If we're talking in the vocabulary of Containerlab, clab deploy -t, and I'm going to specify the topology definition file name, which is storm.yaml. Storm.yaml, correct. So let's give it a few seconds until it spins up my lab. Basically, as you can see, we have already the clab-storm folder automatically generated by Containerlab, which contains all the relevant files for this specific web and topology. So yeah, basically in VS Code you can do it using the Containerlab extension as well. So I'm still waiting until it finalizes the deployment. Might take a few seconds more. Not that much. Yes, and we're done here. So we have switch 1, switch 2, switch 3. Those are the host names. We're running Arista EOS 4.34.1f. So I can show you the Docker image. This is the Docker image. Now, if you are wondering how to download and install these Docker images into your Containerlab, or Docker engine, you can check out the previous videos in this playlist. So yeah, basically now we can go ahead and open the Containerlab extension for VS Code, and if you open it, you will basically just hit on the name here and it will display the topology for us. As I said previously, it's a triangular fashion, triangular topology, so we can obviously just hit on this unlock button and probably just change the position of our switches if we want to. It acts a little bit weird for some reason. Oh yeah, that's okay, whatever, let's just keep it this way. And the other cool thing I want to display is you can basically come over here and toggle YAML split view, so it will also show you the topology definition file here. And then if you come over here and just hit this button, which is fit to viewport, you can just make it neat and clean. So on the right side we have the skeleton of this lab file, right? On the left hand side we've got the topology viewer, which displays the topology, the logical topology, and at the bottom we have enough space for our terminal in which we can SSH into devices. So what I'm going to do is, you can direct SSH by clicking the right button of the mouse and hit SSH. As you can see, it automatically SSH in the device by running this command, and then you put in the password, which is also admin. Right, so I'm gonna split this terminal and I am going to connect to other switches as well, and I'm gonna split it again and I'm gonna connect to switch 3. Good. So now we've got, and I can basically hide this Explorer part because we don't need it. So yeah, basically, as you can see, it looks very clean, and basically in one window you have everything, pretty much everything you need to manage this web, and you can easily navigate between like tabs and windows. So yeah, let's go ahead and just start wreaking havoc in this particular small, simple network. So before that, let's also just open Wireshark to capture some packets. Let's say we want to capture some packets between switch 1 and switch 2, this Ethernet 1 link. I'm gonna hover over this link and click the right button of the mouse, and let's say we want to inspect this part of the interface of the link. So I'm just going to open up Wireshark packet capture, and it will show me packets traversing this link. So as you can see, obviously by default STP is enabled on all switches to automatically prevent loop problems, obviously. And yeah, we have also some LODP messages going back and forth. Now we're gonna basically disable STP. Before that, I'm just gonna show you what's going on in my case. So these switches don't have any config. Sorry, I have to say enable, just forgot about it. Yeah, nothing special, just like automatically generate config by Containerlab. And yeah, so if I say show spanning tree, we'll see that basically we have two interfaces. One has a root role, the other is an alternate, which means it's in discarding state. So if we go back to what we can do, we can get rid of this because we don't need to modify anything right here now. So I'm just going to close this, and I am going to basically put this part here, the Wireshark part here, or here, it doesn't really matter. I can a little bit extend this window because Wireshark output is more interesting, and here we have enough space to display our logical topology. Yeah, so what happens is we've got this topology, and as you can see on the CLI output, it's for switch 1 Ethernet interface 1 is in forwarding state. It forwards STP packets, and then Ethernet 2 is in discarding state, which means currently this port is disabled for STP BPDUs and basically all other frames, Ethernet frames that might cause loops in your network. So I'm gonna do the same thing here, show spanning tree. For switch 2, we have both interfaces, Ethernet 1 and 2, forwarding, because this bridge is the root. Now switch 2 is the root of this spanning tree, right? And then if we do the same command on switch 3, we will see a similar situation to switch 1. We've got one interface, Ethernet 1, forwarding, but we also have Ethernet 2 forwarding, although it's designated role. So now what we can do is basically disable spanning tree in all of these devices, and then do some simple pings to cause chaos, right? So to disable spanning tree on Arista EOS, you need to go to the configuration mode, and then you need to say spanning tree mod none, because mod none will disable spanning tree. So I'm going to say spanning tree mod none, and I want you to pay attention to this part, right? Because here you will see a lot of interesting things. So right now, as you can see, STP packets are here. They are coming, they are showing up, and they are doing their best to just talk to each other to make sure that network is loop free, right? But it's not gonna go forever. Now I'm gonna start with switch 1. I'm gonna say show spanning tree mod none, and as you can see, we still have some STP packets showing up on Wireshark. Why? Because switch 2 and switch 3 still transmits their BPDUs. So the same thing will happen in switch 2. So enable, go to configuration mode, spanning tree mod none, and we still have some STPs obviously showing up, and the same thing will happen on the last switch in this topology, and that should stop STP packets from showing up on Wireshark at all. So again, enable, configure, spanning tree mod none. All right. So as you can see, the last ID of the packet was 174, the last STP packet. And after this, we'll have only LLDPs coming up. Now, we could also disable LLDPs, but I don't think it is necessary. We can keep it because it's not bothering us. Okay, so now I'm going to show you a few more CLI commands just to give you an idea of what's going on. So show MAC address table is going to show us the current state of MAC address table. As you can see, there are no entries at all. And the same thing is applicable to all the other guys here, right? Empty MAC address table, because we haven't sent any packets or haven't received any packet, because basically these switches are not configured to do anything yet, right? there should be a few commands to obviously check the status of CPU in Arista EOS. So probably it was show CPU not supported on this hardware platform. Okay, maybe in the bash shell we can run some top command. Yeah, that would be one way. So currently the CPU usage is very low, as you can see here. But I'm gonna also show this in my local workstation. I'm just going to open a new terminal tab, and I will use btop to show you what's going on right now. So right now, as you can see on the right hand side, we've got the CPU information. So we have like 27% of usage. Obviously it varies, it changes every single millisecond almost, and all the cores and threads are shown here as well. So here we have also the RAM information, storage information and everything, and the processes that are running right now. So now I am going to configure IP addresses on VLAN interfaces. Now by default, obviously we have VLAN 1 on all switches, so I'm just going to use the same VLAN. So I'm going to say interface VLAN 1, IP address, let's say 192.168, let's say 1.1, why not, /24, and I'm gonna say the same thing here, but a different IP address. So let's go 192.168.1.2/24, and obviously here same thing, 192.168.1.3/24, right? Okay, so we have our IP addresses in place and interface is up and running. So now I'm going to do an interesting thing, and I will have like multiple switches here. So let's on switch 3, let's basically just run this command, show logging follow, to see the real-time logs, right? So we have some logs from the STP that it was disabled, and interfaces have been removed from the multiple spanning tree instances and everything, but those are the older logs. But now we will see newer logs popping up after I start pinging. Let's say we can ping switch 3 from switch 1, right? And let's see what happens. So, and what else? And here we can just check the show Ethernet. Sorry, I always mix this with Junos, because on Junos, to view the MAC address table, the command is show Ethernet switching table, but on Arista EOS, it's obviously show MAC address table. And can we use some pipes here to refresh the output automatically? I don't see it. No more JSON, include, exclude, begin, append, blah, blah, probably not. Okay, just show MAC address table. Yeah, it's empty now. And here I'm just gonna do the ping. So you don't even have to do anything crazy, because you need a few packets to start chaos in your network. Like, you don't need to, I mean, we could in principle, right? We could in principle, let's specify the IP address of switch 3. It's going to be 192.168.1.3. And yeah, so I was just going to tell you that, for example, there are some parameters for ping that you can repeat by specifying repeat count, or you can even indicate the size. For example, the size of a packet, you can put the maximum if you want, but there is no need for that, right? There's no need for that, because you just need a few packets to start broadcast storm in your network, and by default, if I hit enter now, it will send only 5 packets, right? And that 5 packets will be enough to start the chaos. So yeah, we have our Wireshark here. As you can see, we don't have anything else, just ODP packets coming and going, nothing from STP, right? And in this side we have some logs, real-time log display, but no logs have shown up since I ran the command. And I am also going to show you the status of my basically CPU again. As you can see, it's 30% overall, 28, you know, it's changing every once and then, but it's fine. Now I will go back and I will hit enter and check out what happens. Now we have 2 packets that were successfully transmitted, but we've got 60% of packet loss, and as you can see here, the symptoms of chaos have already started to show up. Infinite amount of R packets asking who has this IP address. Now we can capture one of these and we can take a closer look at these. So the sender IP is 1.1, which is switch 1. Target IP is 1.3, which is switch 3. And can I basically go more? And my laptop is already kind of going crazy. And if you look at this part, you can see that we have real-time logs started at this time, saying that interface is flapping, host flapping here. And we will get these host flapping interfaces forever, okay? Because just a few packets are enough to continuously loop around, right? We started the ping from this device, targeting this device, and since this port was blocked due to STP, but then we disabled STP, it doesn't matter, so like we can go this way or this way, but whatever way you go, since all of these interfaces are now enabled and passing all traffic, right? And there are 2 possible destinations to reach this basically interface VLAN here. It will just continue going through and through. So if you go to switch 2 and if you hit this command again, you will see that we have 2 entries in the MAC address table right now, and it is showing us certain MAC addresses. So if you look at here, if you say show interfaces VLAN 1, it will show you the hardware address, and DFCA sorry, belongs to switch 1. So that's the entry. So switch 2 learns this entry from Ethernet 1 interface, which is here, which makes sense. But if you run this command again, you will see that, oh, now switch 2 learns the same entry from a different port, from this port, and it will continuously basically change. So if you run it multiple times, yes, again, we came back to this. So this is how easily you can basically crash your network, right? This is exactly why disabling STP is not recommended and can have devastating consequences in your production network. So never do it on your production network. This lab is for demonstration purposes only, and also just to show you how nice this window looks on VS Code. We've got Wireshark, minimal version of Wireshark running here, and we've got the top viewer showing us the logical topology, and we've got the integrated terminal of VS Code in which we have splitted tabs or windows or panes, and we can basically work and fiddle with all the devices in our topology, right? So, and lastly, I'm just going to show you what happens on my laptop. As you can see, the CPU percentage, the usage is has increased significantly. You can see the graph here, This is when we started pinging the switch 3, and yeah, you just see the graphs. It's an insane amount of increase, and I can continue doing this, but my laptop will eventually fry, and I don't want my laptop to get fried. But like, what we can do is we can a little bit increase it, right? We can maybe make things a little bit spicy by doing another ping to, let's say, to switch 1 from switch 2. Again, similar symptoms, right? 5 packets transmitted, 2 received only, and 60% packet loss. Now it can be like, it can change. So right now it's 40 packet loss because it's unstable. Sometimes it even can be without a packet loss. So I've sent a few packets, and that could obviously cause, so if you just go to the bash shell and if you run just top to also show you what's happening here, as you can see, the CPU increased significantly here, right? And on my workstation, yeah, it's a little bit more crazy. So what we can also do, we can go even crazier than that, and we can say, let's ping this host, let's say size, let's put the maximum size. So my video can stop abruptly, guys, because I'm sacrificing my laptop here just because I want to have some fun. What else we can do here? Obviously we can go to the repeat count. Let's just say 1 million or whatever. Let's go. Fragmented IP protocol. We've got different scenarios popping up here. Let's see how it affects my laptop. Pretty much the same, nothing crazy. And we do get some responses. Let's do another ping here. Yeah, so that's pretty much it, and yeah, that was it for today. So I'm just gonna stop this madness. Sorry about it. So how you can stop it by re-enabling STP obviously, or by just disabling one of these interfaces, or let's just say what's happening here, show IP interface brief. Yeah, we're just gonna go to configuration mode and disable VLAN 1 interface, shut down, and this should make things simpler, relatively of course, because we have to disable other interfaces as well. Interface VLAN 1, shut down, and interface VLAN 1, shut down. Yeah, now some packets will still increase here, obviously, because I have indicated an enormous size and repeat count. I think it was 1 million or whatever. So that's why, yeah, it will a little bit continue like crazy, but it will end at some point. Yeah, the CPU percentage is still crazy here. So like we've got the remaining packets still making trouble. But anyway, that's pretty much it. That's what I wanted to show you today, and yeah, a simple video I guess, but just showing you how it could impact your network. Thank you for watching everyone, and yeah, see you in the next video, I guess.